Unit 1B, Lesson 2. This lesson will align with 6.5 and 6.6 in your textbooks. Two standards to discuss in this lesson. The first one, know and apply the remainder theorem. For a polynomial p of x and a number a, the remainder on division by x minus a is p of a. So p of a is equal to 0 if and only if x minus a is a factor of p of x. The second standard, identify zeros of polynomials when suitable factorizations are available and use the zeros to construct a rough graph of the function defined by the polynomial. The remainder theorem. If a polynomial f of x is divided by x minus k, the remainder is r equals f of k. The remainder theorem tells you that synthetic division can be used to evaluate a polynomial function. That is, to evaluate a polynomial function f of x when x equals k, divide f of x by x minus k. The remainder will be f of k. Right now, I'm sure this is really confusing. We're going to go through a couple of examples to help you understand how synthetic division and our remainder is going to be related to if we just plug that value into the function. First example, evaluate polynomials using synthetic division. So we are essentially dividing x cubed minus x squared minus 2x plus 8 by x plus 2. If we're dividing by x plus 2, that's a linear binomial. We can use synthetic division. Recall how we set up synthetic division. We're using the coefficients of our first polynomial. We have 1, -1, -2, and 8. The value we put outside the box is what we're dividing by over here, which will be a -2. Bring down our first number, multiply -2, add vertically -3, multiply +6, add vertically 4, multiply -8, and we get a remainder of 0. What the remainder theorem tells us and our first standard, if we go through and use synthetic division, we get a remainder of 0. That means x plus 2 is a factor of our original polynomial. So if we took our original polynomial x cubed minus x squared minus 2x plus 8, this will factor into x plus 2. And now we have to use our coefficients down below, which will be x squared minus 3x plus 4. So since we got a remainder of 0, that tells us x plus 2 is a factor of the original polynomial. What this also tells us is if I would take f of -2, meaning if I plug -2 in for x in our original polynomial, our result is going to be 0. So you can go ahead and do that. I assure you, if you plug -2 in for x, your answer is going to be 0. That is what the remainder theorem is telling us. That's what we're trying to understand from our first standard. Going to go through another example like that. Divide x cubed plus 2x squared minus 6x minus 9 by x minus 2. We're dividing by a linear binomial, so we can use synthetic division. Coefficients are 1, 2, -6, and -9. The value we put outside is going to be a +2. Bring down our first number, multiply across, add vertically, multiply across, add vertically, and multiply across. The remainder is -5. So according to the remainder theorem, since we got a remainder other than 0, that means x minus 2 is not a factor of the original polynomial. Alright? This also tells us that if we would plug in 2 into the original polynomial, if I plug 2 in for x in this original polynomial, the result will be -5. And you can go ahead and use your calculator or use mental math to plug 2 in for x and see for yourself that the result is going to be -5. That is using the remainder theorem, which is the first standard for this lesson. Next example, reviewing something we've covered in the past. Write a polynomial of least degree with the given roots. So if we know these are the roots, we can write these in factored form. So if x is equal to 2, that means x minus 2 is a factor. Negative 2 means x plus 2 is a factor. And 4 means x minus 4 is a factor. First two should be able to recognize this pattern. This is going to be the difference of squares pattern, which will result in x squared minus 4 times x minus 4. Now we have to go through and use the FOIL method. X squared times x is x cubed. X squared times negative 4 is negative 4x squared. Negative 4 times x minus 4x. And then negative 4 times negative 4 is positive 16. So if we know the roots are 2, negative 2, and 4, we can write those in factored form and then simplify to get a polynomial of least degree that has these given roots. To end this lesson, we're going to review the zero product property, also known as the zero factor property. If the product of two or more factors is equal to 0, then one or more of the factors must be 0. If we have a times b is equal to 0, that is true if and only if a equals 0 or b equals 0. In this example, we want to solve the polynomial using the zero product property. If we have a polynomial in factored form, 2x minus 3 times x plus 7 times x minus 11, if we have it in factored form and it's equal to 0, we can set each of these individual factors equal to 0. So we set 2x minus 3 equal to 0, set x plus 7 equal to 0, and we set x minus 11 equal to 0. Now we go through and solve each of these linear equations. On the left, first we have to add 3. So we get 2x is equal to 3, then divide by 2. So x is equal to 3 halves. Next one, all we have to do is subtract 7. X equals negative 7. And the last one, add 11. So x is equal to 11. If you can get a polynomial into factored form and that is equal to 0, then we can use the zero product property to solve that polynomial. A key part some of you may mess up. If we have this in factored form, our factored polynomial has to be equal to 0 on one side of the equation in order for us to use this property. In this example, we want to find the roots of the polynomial and use them to sketch a graph. We have f of x equals x squared minus 7x plus 10. We want to get this down into factored form. F of x is equal to, we need to find factors of 10 that when we add together give us negative 7. Since our b value is negative and c is positive, we know both factors have to be negative, negative 5 and negative 2. This factors into x minus 5 and x minus 2, which means two of the roots are going to be, if we would use that zero product property, set this equal to 0, x minus 5, x minus 2. Now we can use the zero product property. X minus 5 equals 0, which implies x is equal to 5. X minus 2 equals 0, which implies x is equal to 2. So if those are the roots, they're the zeros, they are the x-intercepts of the graph. So one of our x-intercepts is 2, the other one is 5. If you look at our original, we need to determine whether this opens up or down. Our a value, the coefficient in front of x squared, it's implied to be 1, which is positive. Positive is a smiley face, so this is going to open up. So our graph is going to look something like this. Get our polynomial into factored form. Use the zero product property to find the roots, which are the x-intercepts of the graph. Plot the x-intercepts, determine whether it opens up or down, and sketch the graph. In this last example, we're going to use everything we've discussed so far in this lesson. Find the roots of the polynomial and use them to sketch a graph. We have f of x equals x cubed minus 3x squared minus 6x plus 8. We're told negative 2 is a root to this polynomial. Since this is x cubed, we need to find the other two roots. We're going to use synthetic division to do that. So we set up for synthetic division, we use our coefficients. 1, negative 3, negative 6, and 8. And we're going to use negative 2. Since we're told this is a root, we should get a remainder of 0 when we go through this. And then the polynomial we're left with, we can factor that down afterwards. Bring down the 1, multiply negative 2, add vertically negative 5, multiply across 10, add vertically 4, multiply across negative 8, and we get 0 for a remainder like we said we should because negative 2 is a root. Using the remainder theorem, now we know that f of x will factor into x plus 2. And now we have this quadratic, which is going to be x squared minus 5x plus 4. Looking at this quadratic, we can factor this down further. So we have x plus 2. Factors of 4 that when we add together give us negative 5. This will be x minus 4 and x minus 1. Now we have this in factored form using the zero product property. We set each of those factors equal to 0. Our x values are negative 2, positive 4, and a positive 1. Those are the roots, they're the zeros. They will be the x-intercepts of the graph. So now if we go down below and plot this, we have negative 2, positive 1, and 4. So we have 3 x-intercepts. We want to draw a rough sketch of this graph. Going back to our original, our a value is positive, and since this is cubic, our graph will be increasing from left to right. Starting down here, we're going to be increasing, have to come back down, go back up, and are increasing as we go to the right. So here's a rough sketch of our graph. First, since we were told this polynomial has a root of negative 2, we could use synthetic division and the remainder theorem to factor the polynomial down more. Once we have it in factored form, we can use the zero product property to find all of the roots, which are the zeros, which are the x-intercepts of the graph. Then, understanding that the a value is positive, we know going from left to right, our graph has to be increasing. So here's a rough sketch for this graph. In this lesson, we went through a lot of information. We need to understand how we can use synthetic division to get a remainder and relate that to if we plug that k value back into the original polynomial. Also have to understand the zero product property and how we can use that to find the zeros of a polynomial in factored form. And then relate those zeros to the x-intercepts of a graph to draw a rough sketch.